pathogens by molecular experimental techniques. And the polymerase chain reaction, abbreviated as the PCR, is a molecular biology technique used to amplify the specific DNA fragments, and it can be considered a special form of DNA replication outside the organism. And the key feature of the PCR is it is its ability to significantly increase minus amount of DNA. So I remember that last time we conducted the training, we said that theoretically, if the reaction materials within the system is unlimited, the amplification signal in the PCR will be theoretically be infinite amplified. But in the for today's training, we need to clarify that the nucleic acid testing is not equal to the PCR. They're not actually the same thing. And I know that you might gonna ask, what is the difference between the nucleic acid testing and the polymerase chain reaction? And or you might want to know what is the relationship between each other? And we can have a look of the standard procedure of the nucleic acid testing. As a standard procedure of the nucleic acid testing must go through 5 steps, and each step is crucial to the result, and each step will influence the final results of the test. And PCR, the polymerase chain reaction, is the most critical, is the most crucial technical steps within the whole process within the nucleic acid testing. But it is not the only step in the entire process. And the whole nucleic acid testing process also includes the sample collection, which is the sampling, and the nucleic acids extraction and purification. Also, I wrote the sample preparation because these steps is also really important. And you know that when you're conducting a nucleic acid test of our products, of the inside machine and the matching regions, we must go through a procedure of the sample preparation. And we finish the de-amplification process, and we will detect and analysis the final results. So before we moving forward, I want to ask you a question is, what is in cycle? Can you hear me right now? I would like to ask you a question is, what is in cycle? Just you can have a brief introduction of the in cycle machine. Yeah, the nucleic acid testing machine, right? And when you get into the clinic to introduce the Incycle machine to the clinical doctors or the vets, you would often you might gonna often have this kind of brief introduction of the Incycle machine. So we can have a review. So the Incycle machine is a fully automatic in clinic nucleic acid testing equipment, and it integrate the nucleic acids extraction, purification, and the PCR amplification and the detection. together within a whole system. So the in cycle is more than just a PCR machine. It is kind of an equipment which is using the most classic and standard method from the nucleic acids extraction to the amplification and detection and finish the analysis of the testing results. So all the doctors or all of us have to do is finish the sampling process and finish the sample preparation and and let the in-cycle machine to do the other steps, and they can get the reports within 2 hours. Normally, we've been improved the in-cycle machine's testing speed, and normally it will be finished within 1 hours and 40 minutes, right, Rosen? So, as we mentioned before, the in-cycle machine is not only a PCR machine, but why we're going to say that the nucleic acids extraction and purification is so important, or why we need to conduct the nucleic acids extraction and purification. That is because sacrificing the nucleic acids extraction and purification process can absolutely shorten the detection time and reduce the cost. Uh, Based on our experience in the market, we saw a lot of competitive products. They sacrificed the process of the nucleic acids extraction and purification. But based on the doctor's reflection and their feedback, they always gonna say that this kind of machine is not accurate. And this kind of machine, in the early stage, when they're using this kind of machine, sacrifice the process of the nucleic acids extraction and purification, they might get the false negative results. And in the when they after they using this kind of machine for a long time, this kind of machine often provides them a false positive result that represents this kind of equipment, this kind of machine have already been contaminated. So this is the meaning of we conduct the nucleic acids extraction and purification because a lot of unpurified samples might contain the immunoglobulins and proteases and hemoglobins or the lipids, something like that. A lot of kind of substance might gonna be function as the inhibitor of the PCR amplification, which can interfere with the reaction, leading to the reduced sensitivity or false negative results. And additionally, within the sample, if it is not purified, some non-target DNA within the sample might gonna cause non-specific amplification and increase the risk of the false positive results. And also, there is might have a kind of situation is the machine is being contaminated. And before moving forward again, I will also have a question. I also have a question is, do you know what kind of nucleic acids extraction and purification method that we are using right now? So you have no idea, right? Maybe some you can have a review on of the product catalog when you're available. And let's moving on. The the yeah, the non-target DNA is something like when we set up the non-target DNA. I can describe like this. When the machine has been used for a long time and have been used to conduct a lot of tests to detect different kind of pathogens, right? Sometimes the machine has been contaminated by the pathogens, by the samples, like the gastrointestinal samples or the blood sample. They might have they might have the possibility to contaminate the machine itself. So this kind of situation is when we're putting a new sample within the machine to conduct the polymerase chain reaction. The contamination substance within the machine will be also amplified together with the new sample. And this contaminate substance within the machine is the non-target DNA within the sample. I'm not sure if I'm clear about this. This kind of situation mostly happens when the machine is being contaminated. Just like when you're testing the CDV or CPV, right? The target gene is the CDV or CPV. But before you conduct the test of the CDV or CPV, maybe the machine has been polluted. The machine might already contaminated by other pathogens like the microplasma or something like that. And these pathogens genetic materials will be amplified together with the target gene, especially when the quality of the primer or probe is with they don't have such strong specificity to detect the target gene. It will also detect the microplasma or something, the pathogens genes that contaminate the machine. Yeah, okay, let's moving on. I would like to know is what kind of extraction method the Incycle machine are you using right now? Yeah, the magnetic beads method. Okay, okay. And so, as you know that the Incycle machine are using the magnetic beads method for the nucleic acids extraction and purification, and we can have a review of the whole process of the nucleic acids extraction and purification by using the magnetic beads method. We know when we conduct a nucleic acid test, the first step is we collect samples from the animal body, right? And this is the sample collection. And after we finish the sample collection, we put the samples within the tube, which contains the sample diluent to conduct the sample processing, right? And the sample diluent normally are the chemical liquids that are used to lysis the cell's body to let the cell release the genetic materials like the nucleic acids into the sample diluent. And after the nucleic acids has been released into the sample diluent, it will be mixed together with many other substance that we can call it impurities because we only want to amplify the nucleic acids, right? So after finish the lysis of the cell's body, we will use the magnetic beads to binding the nucleic acids. The magnetic beads will bind together with the nucleic acids together. And the magnetic beads will absorb the target nucleic acids. And when we use another magnet to absorb the magnetic beads binding the target nucleic acids, we can wash off the impurities. Did you understand that? And then after we wash off the impurities, and we can move the magnet and release the magnetic beads and the target nucleic acids. And in this stage, what is left within the tube is our target nucleic acids. So we can add, and then we can amplify the target nucleic acids, and all of those impurities has been washed off.
Like the principle, one magnetic beam can absorb like the DNA or RNA, right? I think I don't know how to say in English to 正负电荷.
Yo, I'm questioning about this. How to speak it in English?
Wait, I will Google it right now. Okay.
Okay, let's moving forward, and we will feed you back after we translate this kind of answer. Sorry, I had a bad cough. Can you hear me clearly?
Positive active.
Okay, let's moving on. And this is the whole process of we using the magnetic beads to finish the extraction and purification. So the sample diluent has been purified with only the nucleic acids within the tube. And before question again, before we moving on, keep moving on. I would like to ask, what kind of method is the Encyclo machine using for the amplification? So what kind of amplification method we're using right now? Can you answer me about this question? You can just tell me about the name of the method. The abbreviation of the name of this method is RTQPCR. So the whole name is the real-time fluorescent quantification polymerase chain reaction. Okay, let's move forward. We can have a look of how the quantitative PCR works. And sometimes it might then be abbreviated as the qPCR. It is actually the same thing with the RT-qPCR. The insect machine are using the real-time fluorescent quantification polymerase chain reaction. And we can see that you can have a look at this image. When we are conducting the amplification of the target sequence of the gene nanomaterials, the nucleic acids, the first step is we conduct the DNA denature at 95 degree. And the double standard DNA separates into single standard. Sorry, the this kind of double strings, right? They have two chains bind together. And at 95 degree, the DNA will be separated into two single chains, right? And then we will turn the machine into 60 degree and we use the specific primer or a fluorescent probe to bind the target gene, to bind the target gene, to bind the target sequence. And the probe consists of fluorescent probe and a contrast. And then we still use the 60 degree to amplify to finish the extension because they're attack polymerase. Why it is calling the polymerase chain reaction? Because we're using the polymerase to expand the target sequence and hydrolyzing the probe. And when the when the probe bind with the target gene sequence, it will release the fluorescent signals. And the fluorescent signals is measured at the end of each cycle. So we know that if you have a look of the testing reports, normally within the chart we have 40 cycles. Um, this is kind of exponential DNA amplification. You can have a look at this image. We can raise an example. When we put in one target chain, after one cycle's amplification, it will be it becomes into two target chains. And after the second cycle has been finished, it will becomes four. And after the third cycles, the four will becomes to eight. And after the fourth cycle, the eighth sequence will becomes to how many? 16, right? Yeah, this is kind of exponential amplification. Well, it will be illustrate like the DNA copies increase exponentially because each cycle doubles the DNA quantity, meaning one copy can leading to billions after 40 cycles. The more initial DNA present in the sample and the earlier fluorescence will be detected. And after we finish the deamplification, after we have been goes through 40 cycles, the amplification will become to an end. The amplification has been finished, and we will detect the fluorescent signal by the optical module. So the real-time quantitative PCR determines the readout, which is positive or negative, by measuring the amplification curve. You still remember this picture, right? The amplification curve seems like an S, which is the exponential curve. And after we finish the 40 cycles, the algorithm calculates the increase in the fluorescent signal, which is relative to the fluorescent signal of the earlier cycles. The machine calculates the increase of the fluorescent signal relative to the fluorescent signals of the earlier cycles. This is the earlier cycles. We call it the baseline. And when the signal has been detected, it will comes like this kind of shape, seems like an S. Because every cycle we will detect the fluorescent signal, right? Every cycle. So the axis represents the amount of the cycle, and the white axis represents the fluorescent signals, and each cycle has been finished. We will detect once about the fluorescent signals, the intensity of the fluorescent signal. And after 40 cycles has been finished, the machine will calculate the machine will calculate the increase in the fluorescent signal's intensity relative to the fluorescent signal in the earlier cycles. They will make a comparison between the 40 cycle and the earlier stage of the baseline. And if it is a positive result that represents the target pathogens has been successfully detected, it will show a positive result. And the shape of the curve will seems like an exponential curve. And if there is no target gene within the sample, that represents the animal is not infected, the amplification curve will becomes a straight line with no fluorescent with no changes of the fluorescent signal. The negative result will shows a straight line. And the machine, the inside machine, last time we conduct the training, we mentioned about a really crucial step is we adjust the threshold, right? So the machine reads the results by what? Do you remember that? Yeah, the inside machine, yeah, the inside machine read the result by the intersection of the threshold value line and the amplification curve. That represents at this intersection, the inside machine find the fluorescent signal of the amplification. And after the machine detect the fluorescent signal of the intersect on the intersection, the intensity of the fluorescent signal will be stronger and stronger, will be comes to a exponential curve. This is for this part, it is really hard to understand because when we conduct the training about this part for this part, we find it also it is going to be really hard to explain. But did you understand? But when people when I also have a question is what about the CT value? The positive redox CT value. Do you remember that? Less or equal to 36, right? But there is a little difference with the FCOV, the coronavirus, and the feline infectious peritonitis panel. Do you remember that? The CT value, I still remember there might gonna have some difference. For the FCOV and FIP panel, the CT value is less or equal to 39. This is only 这个是唯一不同的吧？就是这个转复的这个项目
就它的那个
，CT 值。
曲线嘛，对对对。
Yeah, for the coronavirus and FIP panel is the only different. It's only the only different one.
38，
And we can move forward. For the second part, we can have a look of the history of the development of the PCR. And after we finish the part one, I think the most important thing we would like to express is let you clearly know that the PCR is not equal to the nucleic acid testing. And the in-cycle machine are using the most standard method. And the in-cycle machine is more than just the PCR machine, more than just the amplification machine. And we can come into the second part of the history. Because I still remember that last time we conduct the training in Vietnam, the Paul have shared that. Do you remember Paul? Last time the Paul shared with you that the diagnostic method within the animal health care well undergone with three major development stage. Do you remember the stage? For the first stage is the empirical diagnosis, which which means that the veterinarians diagnose the disease by their own experience, right? And in the early stage of the veterinary medicine, the diagnosis pri- primarily relies on the veterinarian's clinical experience, and those diseases were inferred based on the clinical symptoms, the medical history, and the epidemiological characteristics. For example, we can raise an example. When an animal exhibit fever or respiratory symptoms, a a veterinarian might empirically or judge the disease by their own experience. Oh, this case might for this dog, it might got infected by the canine distemper virus or some bacterial pneumonia or the initiated and finish the treatment by initiated treatment. Can you hear me? It's like in the early stage, when a dog shows the symptoms of the fever or the respiratory symptoms. And in this stage, because in the market, we lack of diagnostic, in vitro diagnostic machines, or in that stage, we don't even have the rapid tests. So we can only judge the disease by experience. But however, in this kind of stage, this kind of matter lack of the objective laboratory data and leading to a higher risk of the misdiagnosis and difficulty to distinguish between different kind of pathogens. And we can say that totally there is no method in this stage to distinguish different kind of pathogens shows similar symptoms. And and then we developed into the second stage, the evidence stage. As the veterinary diagnostic techniques advanced, the laboratory testing become widely adopted, making the transition and to the evidence-based diagnosis. And at this stage, diagnosis were based not only on the clinical experience, but also on the pathogen detection, like the hematology machine, which is the CBC machine, and the biochemical analysis machine, and the immunological tests, like the rapid tests, comes into the market, and the bacterial culture in this stage function a lot to help the veterinarians to conduct the clinical diagnosis for the disease. And this method significantly improved the diagnostic accuracy. However, they still have some limitations, like the immunological method, like the rapid tests, still have a lot of limitations. Like for the culture, the long culture times, the culture takes a long time, but the time is the key of treatment, right? And the sensitivity is highly limited, and the inability to precisely differentiate between the strains or the resistant pathogens. And then we comes into the precision diagnosis stage. With the advancement in the molecular biology and the veterinary in vitro diagnostic has entered the area of the precision diagnosis. And in this stage, the diagnosis is driven particularly by the widespread application of the PCR technology because the PCR can directly detect the genetic materials and recognize which kind of pathogen the animal are infecting right now, right? Can you hear me? And mm, so for today, this is last time that Paul showed you that the evolution of diagnostic methods in veterinary care. But for today, I would like to share with you the history of the development of the polymerase chain reaction. Because actually, the PCR, polymerase chain reaction, is already not something new. It's not a new thing. The PCR was firstly introduced in 1983 and refined in 1986 with the discovery of the tech DNA polymerase. and it allowing for automated high temperature amplification. And this breakthrough leads to the commercialization of the PCR instruments and the PCR widespread adoption in the genetic research. This is the first stage of the PCR was initially discovered. And then in 1990s, the real-time quantity PCR, like the inside machine are using right now, was developed. And it is integrating the fluorescent probes to enable the real-time monitor of the DNA amplification. So this advancement allows for the quantitative pathogen detection and making the qPCR a crucial tool in virology, bacterial diagnosis, and gene expression studies. And for today, to the 2000s, we still developed some new methods for the amplification. The first one is the digital PCR, which is the most accurate methods within the whole market. But I don't think there is any kind of method like the digital PCR right now because the cost of the digital PCR machine is really, really high. And another kind of method is the isothermal amplification, which we call it the lamp method. This is like the can be recognized as the fastest method within the market, and I'll introduce you these two kind of method later. And so for the third part, we will have a comparison of each kind of method. You can have a look of this table because uh like I said before, for the insect machine, it's more than a PCR machine. So for today's sharing, I will not only introduce you the different kind of the amplification method, but also we will tell you there also have different kind of extraction and purification method within the market. So I'd like to discuss four common nucleic acid extraction methods. For the first one is the column membranes method. The column membranes method. So this kind of methods is one of the most widely used methods within the lab. So still for today, still there are a lot of labs are using this kind of method to finish the nucleic acid extraction. And this kind of method relies on the nucleic acid binding to the silica membranes, while while the impurities were washed away by using the centrifugation or vacuum filtration. And this kind of method is known um, for today. Still, a lot of people recognize this kind of method. We can recognize this kind of method as the conventional extraction method. And for this method can be known as the high purity and stability, making the extraction ideal for the quantity PCR and sequencing and other kind of high precision applications. But for this kind of method, you can see the automation level, this kind of method is really, really low. And it is must be operated by human. That is why we're saying that this kind of method is widely used within the laboratories, but not within the clinic because it cannot be automated. Because this kind of method cannot be automated. And I know that it is going to be really hard for you guys to clearly understand the principle of each method, but you can have a look of the comparison of the each kind of you can have a comparison of each kind of method for the advantages or disadvantages. Because the the column membranes method requires multiple manual steps, and the the centrifugation equipment, which mainly limited its suitability for the rapid and the automated workflows. And the second method uh, is the magnetic bead method, which is the Incycle machine are using right now. And the magnetic beads extraction works by using the hydro. This is the question you asked before. The hydro, the hydrophilic magnetic beads that bind to the nucleic acids, allowing for the separation through the magnetic field compared to the first method we mentioned before. This method, the magnetic beads method, comparing with the column membranes method, this kind of methods approach is highly efficient and well suited for the automation because it can be fully put it can be fully designed into the Incycle machine, and this kind of method is finished by the mechanical arms within the Incycle machine. I remember that last time we show you the inside of the Incycle machine, you saw a lot of mechanical arms working, right? And the mechanical arms make it ideal for the high throughput, just make it a high clinical and veterinary diagnostics. Well, it offers excellent purity and scalability. And the downside is it requires specialized equipment and has higher region cost than the first method. But this kind of method can be fully automated. And the next extraction method, we cannot call it a extraction method because I said before, some kind of brand or some machines might sacrifice the extraction process and the purification process to improve the speed of the tests. This kind of method, we call it the extraction free or one-step method. They only use the lysis buffer directly release the nucleic acids, which is the first part of the magnetic beads method, and then they do not extract it anymore, and they ignore the impurities within the lysis and directly put the sample into the PCR machine to conduct the test. So the purity of this kind of equipment and reaction system is really, really low. Like when we're conducting the blood test or the gastrointestinal samples test, all, all of those impurities, like the fecal samples, like you know, like the proteins, the lysases, the lipids within the sample region, will be still within the tube. We know that this kind of matter is really, really fast, and because it do not requires the nucleic acids extraction and purification, so people do not need to conduct the sample preparation anymore. So the efficiency of this kind of method is really high. But as I said before, those impurities might gonna influence the accuracy of the final results. Just like when we conducting the simple samples like the gastric, like the respiratory samples, this kind of samples is really it's not that complicated. But when we conduct so the testing result of the this kind of method, the one-step method or no extraction method, seems similar with our magnetic beads extracted method. But when we conducting the test for the complicated samples like the blood samples or the gastrointestinal samples like the fecal swab or something like that, a lot of impurities will influence the accuracy of the final result. So this kind of methods machines that are using this kind of methods, they all of them have the feedback is that the veterinarian say that this kind of method is not accurate. I'm not gonna using this kind of machine anymore. And for the last one, we call it the microfluidic based extraction. And because this kind of method is not actually an extraction method, just they integrate the microfluidic technology into the extraction method. So I'm not gonna introduce you this kind of method today. All you have to remember that the microfluidic technology is not a method for the extraction. It's only a technology integrated with the extraction method. So within this picture, we compare the different method through the accuracy perspective and the convenience perspective. You can see the magnetic beads method of the Incycle machine and a lot. Also, there are a lot of kind of brands in the market are also using the magnetic beads method. And both the accuracy and the convenience is the highest. So the magnetic beads methods for the nucleic acids extraction is the best solutions to design a kind the to design the machine for the in vitro diagnostic market because we need to clear about we need to clear about the application scenario of each kind of method. For the first method, the column membranes method are widely used within the labs, and this kind of method cannot be automated. So the convenience of this kind of method is not really high because it is not automatable. And for tech, the microfluidic technology, it is not a method. So we actually do not need to compare this kind of method with other kind of methods. And comes into the no extraction or one-step method because they sacrifice the accuracy to shorten the detection time with a high rate of false negative results in the early stage and high rate of false positive results in the later stage. This represents the machines might have already be contaminated. And do you clear about why the rate of the false negative is really high in the early stage and the false positive results is really high in the later stage? Yum, can you hear me right now? And can you tell me why the false negative rate is really high in the early stage? Mhm. Yeah, because it is not purified. Yeah, no, no, no. The contamination might gonna cause the false positive, and the impurities might gonna cause the false negatives. So that is why the feedback of this kind of methods, the machines are using this kind of methods is not really good. And the doctor's reflection and feedback is this kind of machine is not accurate. So because in clinical usage, the technicians and the veterinarians are not that professional to conduct the nucleic acid test, right? So people normally need to have a kind of machine can be highly automated. This is the first demand. This is the first requirements of the customers. The operation must be really, really convenient. And also, people gonna say, if I already spent a lot, if already I already spent a lot of money to conduct the PCR test, the accuracy must be really, really stable. Otherwise, because you know that before the in-clinic nucleic acid testing equipment, the PCR machine, in-clinic PCR machine get into the market, people are normally, well, people normally send the samples to the labs, right? So they will naturally, very naturally compare the in-clinic nucleic acid testing equipment with, they will compare the result of the in-clinic machine with the third-party labs. So the accuracy is also a really important thing for the doctors or veterinarians in clinic. So the Encycles machine, the magnetic beads machine, is going to be the best solution to encounter to satisfy not only the accuracy requirement but also the convenience requirement of the clinics. So this is the extraction and purification method. And question again, I would also like to ask what kind of method the Encycle machine are using for the amplification. Yeah, the real-time fluorescent, uh, sorry, real-time fluorescent codification polymerase chain reaction, the RT-qPCR, can also be called as the qPCR. So we can make a comparison of those amplification methods are normally you can find that you can find within the IVD market. So let's keep going on. So there are four major DNA or RNA amplification techniques. For the first one is the conventional PCR method. And the second one is our real-time fluorescent codification polymerase chain reaction, the qPCR. And the third one is, as I said before, it is the really, really accurate technology. This is called the digital PCR. It is the real codification method. And another kind of method is called the isothermal amplification method. The lamp is one of this kind of method. So for the quantifications perspective, the conventional PCR is not a quantification method. Do you remember that? If do you encounter, have you ever see this kind of method within your school or within the lab of the school, the conventional method? Only one time, right? Mm, so let's go get started with the conventional PCR. The original amplification method of the polymerase chain reaction is the conventional PCR. It is it is really simple, reliable, and widely used in research and diagnostics. But also it has some disadvantages because for the first one, because it is not fully automated. So this kind of method need a special person and with strong ability of the you know to conduct the tests. So it is time consuming, requires the gel electrophoresis for the result analysis, and it cannot codify the amount of the DNA because it is not a codification method, and only confirming the presence of the genetic materials or the absence of the genetic materials. And as for the sensitivity, we can only say that this kind of method has a moderate sensitivity. We cannot say that this kind of method is the most accurate because the manual extraction, manual amplification, the manual operation brings high risks of the contamination within the process, different like the fully automated machine, and make it less ideal for the detecting of the low copy pathogens when an animal within the body contains low copy of the pathogens within the animal body. The final result might gonna shows a false negative result because this kind of method is not that sensitive. And also, this kind of method is time consuming. Normally, this kind of method to finish the conventional PCR normally needs 3 to 5 hours. And as for the second one is our qPCR. And the in-cycle machine are using the qPCR method. And I can actually tell you that the qPCR has been recognized as the gold standard during the COVID-19 period. This kind of method can be recognized as the game changer, unlike the conventional PCR, the qPCR allows us to monitor the DNA amplification in real time by using the fluorescent probes. You remember I said that every cycle finished, the machine will read the fluorescent signals once, right? The detection module will test the fluorescent signal every cycle finished. So the machine will detect 40 times. So we can say that this kind of method is highly sensitivity and specific, making this kind of method ideal for diagnosing infectious disease and provide quantitative results. It's not the qualitative results, it's a quantitative results. Not only the positive or negative, but also provides us with the CT value. So this is essential for measuring the viral or bacterial loads. We can evaluate we can evaluate the viral loads within the animal body by the fluorescence signal. And importantly, it is fast because this kind of method can be conducted all by the machine. So no need to be conducted by the special technicians. No need for the special training. Only conduct like the inside machine. We only teach our customers once how to use the machine. They will clearly know how to use this kind of task because it can be fully automated. And for the next one is the digital PCR. This kind of method can be recognized as the most accurate method. And this is for the insect machine and for the qPCR method, we will recognize we say even though we say that it is the quantity, it will provide us with a quantity result, but it is not a real quantity results. Only the digital PCR, the dPCR, will provide us with the absolute quantification results. Will clearly recognize how many virus, how many bacterial, how many bacterials within the sample. So this kind of method is the most accurate one. It has the highest sensitivity and highest specificity. But also, this kind of method is really, really expensive because the machine is really, really the machine. I can say that the machine is really expensive, and I didn't see any kind of machine are using this kind of method because clinics cannot afford this kind of method. And for the last one is the isoterminal amplification. Um, the lamp method is one of the isoterminal amplification. This is also a semi-quantitative provides us with a semi-quantitative result. But for the report, it will only recognize positive or negative, will not provide us the CT value. And also, this kind of method is highly sensitive, but because of the sensitivity is too high, they will not release. Imagine it, within a community, there might have there might gonna have good people and bad people within a community, and the policeman might gonna recognize the bad guys, the bad guys within the community, right? You can imagine this. I'm just reading a sample. Within a community, just like there are 10 people within this community, and there is one thief within this 10 person. If we do not want to release any bad person, the best solution is we catch them together into the prison, right? Can, can you understand this? If you if we do not want to release the bad guy, we can catch all of these 10 people together into the prison. And this is can recognize a sensitive the highest sensitive method. So, but if we catch everyone within two, if we catch everyone into the prison, what about the good people? So For the specificity, is that we do not catch any of the good people. We only catch the bad guys into the prison. So for this kind of method, because it provides highest sensitivity, so the specificity of this method might gonna become lower. And what kind of product we're gonna say for the PCR machine? A good products must have the balance of the sensitivity and specificity because the if the sensitivity if the sensitivity is too high, the specificity might get slower. And if the specificity gets too high, the sensitivity might get lower. So a good machine, a good product might must balance these kind of two parameters. So this is the comparison of this full kind of method. And also, I would like to say that this kind of method is not the price of this kind of methods is not really high. So a lot of company and a lot of products might gonna use this kind of method to conduct the amplification because the speed of this kind of method is really fast and provides the people with high sensitivity. But sometimes people will find that when they are using a machine using the lamp master, they will they will find that why is there they will find that sometimes there are false positive results because the non-targeting is also amplified through this kind of method. So, like I mentioned before, the qPCR can be recognized as the gold standard during the COVID-19. You might gonna ask why the qPCR is the gold standard in the diagnostics. So, um, for this question, I'll tell you why I'll tell you why the qPCR well is recognized as the gold standard later, and we can make a summarization of these four methods. For the conventional PCR, the qPCR, and the digital PCR, we can distinguish these methods into the terminal cycling amplification because the temperature of the amplification goes up and down, side by cycling. And for the lamp method, this kind of methods, we can call it or distinguish it as the isoterminal amplification. And this kind of method performed at the constant temperature, which represents the temperature will be fixed, just like if we're gonna use 65 degree, it will be consistent with the 65 degree, and with no need for the terminal cycler. And this kind of method relies on the strand displacement enzymes, rolling circle amplification, and with common methods including the lamps. So the lamp is one of the isoterminal amplification. And also there is another kind of amplification have already used for used into the VAD industry. It is called the isolated isothermal amplification. I'll introduce you this kind of method later. For the advantages of this kind of method, we can say as the advantages of the lamp method is it is really fast. Normally 15 to 60 minutes, people will finish the test to get the report. And with really, really simple equipment because they don't need to have they don't have to set up the module to change the temperature. So the cost of the machine gets lower and either for the point of care testing. But for this kind of method, have higher risk of non-specific amplification, limited to quantification ability, and lower reproducibility. Because normally, for the qPCR, for the Insight machine, we only use one or two universal probe or primer to detect the target gene. But for this kind of method, they need to set up 4 to 6 primer or probes to amplify together with the target gene sequence. So this kind of method is really easy to have to lead to the non-specific binding because the more the primer or probe they design into a one system, the risk of the non-specific binding is going to get higher. So this is the advantages. Even though the sensitivity of this kind of method gets higher, but the specificity gets lower. In this kind of situation, people will easily find the false positive result. And for the conventional PCR method and the qPCR method and the digital PCR method, they can differentiate they can be differentiated into the terminal cycling amplification method. This kind of methods requires temperature cycling. Just like I mentioned before, the temperature goes to 90 degrees and come down to the 60 degrees and cycle by cycle to finish the amplification. So the advantage of this kind of method for the first one is high specificity and high reproducibility. And this is all a kind of quantification method. Also, this kind of method requires specialized equipment because the machine needs to satisfy the requirement of changing the temperature. So the cost of the machine, the price of the machine will get higher than the lamp method. And you might gonna ask, like I mentioned before, why the qPCR recognized as the gold standard in the IVD industry? And I would like to say that for the first reason is the qPCR provides high sensitivity and specificity. It can balance these two parameters. And the second reason is the real-time quantification. It can provide us with the quantification reports. And the third reason is the high reproducibility and standardization. Because this kind of method can be fully automated and don't need a special person or technician to finish the test to conduct the test. So it will be not influenced by the manufacturers. And for the last reason is The qPCR, the speed of the qPCR, even though the speed of the qPCR is not as quick as the LAMP method, but it can already this kind of method can already satisfy the requirement of the disease diagnosis and treatment because within the clinic, people finish the test, they get the results, and they can provide the treating plans for the animals. And if we send the samples to the labs, the pet owners still need to wait, and the speed can already satisfy the requirement of immediate treatment. So for today's last part, we can have a look of this competitive products you might gonna meet in the future. Even though we know that within the Vietnamese market, we do not encounter a lot of competitive products. The only competitor is the third party labs. But I believe in the future you might gonna meet a lot of competitive products. You must know that for the fluorescent immunodeficiency analyzer, there is a brand called WeCheck. This is a brand from Korea. We for the company's name of this brand is called Bionoth. This machine is actually launched in 2022. Different, so we can make some comparison with this method, with this machine and the Incycle machine. The Incycle machine is actually launched in the market in 2018, and for nowadays, we can collect over 1.7 million testing reports as a as kind of backup the statistics to prove the accuracy and stability of the machine. But the VCheck M10 for the price is higher, and because the launching time is not that early as the Incycle machine, they don't have so many data. And from the methodology's perspective, the VCheck M10 from Korea are you actually are also using the magnetic beads method. So the extraction and purification method is actually the same. But for the amplification method, they choose the lamp method. So um for this kind of method, the sensitivity is really high. But sometimes their customers might complain that we indeed they they met some cases which shows no clinical symptoms but recognized as a positive result. This is kind of the false positive result. The higher sensitivity, the lower specificity. And another kind of machine we can often meet in the market, and a lot of clinics have already launched this kind of machine in China. The machine is called Hockey Central. The brand name of this machine is the company. The company is called GeneReach from the Taiwan province, and this machine are using the different kind of amplification method, like I said before. It is called the isolated isoterminal PCR, IIPCR. It's this kind of method seems like the lamp method because the amplification temperature do not change. Um, it is not actually a real lamp method. If you when you're available, you can have a search of this kind of method, the IIPCR online, to have more understanding of this method. And this kind of method, like the lamp method. Um, this kind of method is also not a cannot quantify the nucleic acids. So it is not a re, it cannot provide us with the quantity readout, but a qualitative testing. And after consulting the feedback and the reflection in the market to the clinic and vets that that are using this brand of machine, they said that um, the 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 most disadvantages of this machine is that it is not that full. Um, I'm sorry, just because they said that this kind of machine is really complicated to use, and this after seeing their product catalog, this machine do not have the multiple panel, and the machine only provides the single test, one time, one pathogen. So the application scenario will be really limited. This machine will be on, in my personal perspective, the single tests normally used to verify the clinical doctor's thoughts, to verify their judgment of the disease, but cannot be used to screening the disease, especially for the disease have similar symptoms, just like we have the respiratory 5-in-1 panel because these five pathogens cause similar clinical symptoms. And we have the uh, in-cycle, the gastrointestinal 4-in-1 panel, the blood screening 6-in-1 panel. That is because we want to use this kind of test not only help the doctors to verify their own diagnostic judgment, but also can be used to screening the disease, especially sometimes two pathogens or three pathogens or four pathogens might gonna be infected together. This kind of situation is gonna be really easy to be misdiagnosed, cause the misdiagnose. And as for this kind of technology, because it is the new technology and do not have enough data and evidence to prove the accuracy and stability. And the next one is the mind race machine. I don't know. Do you know this machine, or have you ever represented this machine before? You don't have it, right? This is this machine are using non-extraction method. So just like we said before, many impurities might gonna influence the testing results. And this brand is also from the China, the Shenzhen province, named of Gangzhou. And the machine are using the same method with G-Links. For the extraction method are using the magnetic bead method. And for the amplification method, they're also using the qPCR method. But as you can see, this is the extraction machine, and this is the amplification machine. They are separate between each other. So this is not a fully automated machine. And within this manual operation process, the sample is going to be really easy to be contaminated because you know that the the clinical labs is different from the standard labs. The labs within the clinic is not that clean as the reference lab. So the environment cannot satisfy the requirement of conducting the not fully automated tests. And this is our biggest competitor in China, which called the Newbat. This machine are using the one-step method. For uh for this kind of machine that they're using the one-step method and they sacrifice the accuracy to shorten the testing time. So the PCR test will be finished within only 40 minutes. But a lot of reflection or feedback from the clinic is that this kind of machine is not accurate. And I'll show you this case. This machine is really seems like the Jilin Xin cycle, right? Which is called action. It's also from China. We're using the same method for the extraction, and we are using the same method from the amplification. When we encounter this kind of competitor, do you know how can we cut in the conversation to the clinical doctors? Yeah, just like if you're agent, you're representing for the Incycle machine, and you also encounter a salesman in the clinic. They're also representing the machine with same method, same price, and they provide the clinics with same price, and everything looks the same. So this kind of situation that our salesmen need to know that we need to compare the supplier's strengths and experience to conduct the market education. Because last time I remember that we come into a clinic and we make a conversation with the clinical doctors that the first thing they value the most is the price, right? And the second one is the market education. If we can share with them, we can hold the in-clinic seminar or the training session they value the most. So we can, if we encounter a machine with the same method, same prices, we can tell the customers that if you purchase this kind of machine, after doing a period within the market, if they found that the machine is not sold, cannot be sold well, they will quit from this market, and the machine will live into the hospital, will be lived into in the hospital and become the zombie machine, the dead machine, because the supplier do not provide services anymore. This is also important for the clinics. And another one is whether the supplier can provide them with the education and the training. Because some of the supplier, even that they provide the same product, but they don't have the strength to provide the market training, like the scientific seminar and the in-clinic session. So the service is different. So we can compare with them from the services perspective. And another one is the launching time. Whether this kind of machine have enough accumulation of the data and testing reports to support to be as the backup of the machine. So for today's training, I have been finished.
Okay, thank you for chemistry. I bet you already learned a lot from this training. So I will organize all the material and will send an email to you tomorrow. So if you have any question, feel free to contact us like in the WeChat group. Mm-hmm. Okay. So
And Yum, Yum, can you hear me? I need your reflection. I need your feedback regarding to this training. You can, if there are still any question or problems you still have, you can just write them down and send it into the group, and we will provide you with the answer. And for today's PowerPoint, and I'll also send it into our groups. Is that okay? Ian, can you hear me? Do you have any questions? Maybe later. Okay, okay. You can write it down and send it into the group.
okay, thanks for everyone's time.
Thank you so much.
Okay, so we'll keep in touch. Okay.
We will keep in touch. I believe that you already became really tired. Okay, thanks for your time. And bye bye.
See you. Bye.